Greetings everyone. I am Noorul Ameen, and my registration number is 22BCE1428. And in this video, I'm going to be showing you a demo of my project and also explaining my project for the database system course that I'm currently working on. And this video is divided into four sections. In the first section, I'll be explaining you the brief intro about the scenario I'm working on and the entity and relationships, and the diagram for it for the same. And for the next three parts, I'll be talking about the code that I've worked on, where I'll be interfacing Python and SQL. In which the first part would be about creating the tables, the second part is about inserting values, and the third part is about running the queries. So let's start with the first section where I'll be talking about the scenario. So what I have chosen for this project is that I'm modeling a library management system where the primary goal is to manage books, members, authors, publishers, categories, and the loan transactions within the library. The system helps keeps track of various aspects such as which books are available, who has borrowed them, who the authors and publishers are, and the genres of the book. So talking about it, the entities and relationships used here are, for the entities, we have books, members, authors, loans, publishers, and categories. Don't worry, I'll be showing the entity relationship diagram in a few minutes where you can visualize this. So basically, the entities, like, yeah, as the name suggests, these are like the elements, or what do you call, like the entities where data will be stored or the tables will be created for these entities. So yeah, for books, I have book ID, title, description, publication date, like publication date, and publisher ID and category ID. For members, I have the member ID of the member for the library management system, their names, first name, last name. And then for authors, we have the author ID, first name and last name. For loans, we have loan ID, book ID, member ID, loan date, and return date. For publishers, we have publisher ID, publisher name, and address. For categories, we have category ID and category name. So talking about it, let's move on to the relationship. Now, like, let me show you the relationship diagram, entity relationship ER diagram. Here you can see the different entities that are in like rectangles, the books, loan, members, and publisher, and the relationship in the like diamond symbol. So talking about the relationships, we have like belongs to which tells about which category the books belong to, and published by is related from books to, like, it's a relationship between books and publisher where uh, it specifies which books are published by which publisher. And for like borrowed books, the borrowed book is a weak entity from loan. Like borrowed book is a weak relationship between the weak entity loan and books, as you can see. And loan to will show the relationship between the members, and the loans to show which all books they have loaned. And so, as you can see in this diagram, the books entity is the main entity. So I'll just move on to talking about it more. And so the weak, as I said before, the weak entity is the loan, as its existence depends on both the books and member entities. The weak relationship loan to is a weak relationship because it's dependent on the books and the member attributes. So in the wait 1 second. Yeah, so in the member we have address, which is a composite attribute. So I have tried to include all the different types of attributes, such as like what I've said in address, it's split into different, so it's a composite attribute. And for loan duration, it's a derived attribute from return date. And books can have multiple authors, so it's a multi-valuable attribute. And a descriptive attribute is description in books, like, yeah, description in the book, this one. And then moving on, we can see like, then for mapping cardinalities, book to author is many to many, and book to publisher is many to one. Like, yeah, the definition is also given after. A book can have multiple authors, but an author can also write multiple books. And books to publishers also, books to publishers is many to one, because many books can be published by the same publisher, but not many publishers can publish the same book. Uh, Similar books to categories also, many books can be of the same category, but different categories cannot be of the same book. And loans to members is also same, similarly many to one, because of that same case. And for the constraints, we have participation constraint, we have total participation, and total participation is that the loan must be associated with both the book and the member. So there's a total participation between of loans with books and members. And for partial participation, we have a book or member may not necessarily have an associated loan. So that the other way is not uh, guaranteed. Like it's partial, not fully. And yeah, these are all the I have already explained this in the before itself. And moving on, the requirements is that for the members they can be either students or faculty. Each member has a unique member ID and they can borrow books from the library. Students can borrow up to 3 books at a time. These are 3 books at a time for a period of 15 days, whereas faculty members can borrow up to 5 books for 30 days. Okay, and books have unique ISBN title, genre, and may have multiple authors. And borrowing, when a member borrows a book, a borrowing record is created capturing the date borrowed and the due date. If a book is returned late, a fine is imposed. And yeah, so the fine for late returns is 5 rupees per day for students and 2 rupees for faculty members. Events. The library organizes events such as book fairs and guest lectures. Members can participate in these events at their turns. So we are done with the first section of the video. Now let's move on to the next section, which is about the Python and SQL interface for table creation. So as you can see, for this I have imported the module CS Oracle for the interface, and as you can see, these are the uh, system and like username and password and your connection string. Now, first we start with the connection where we connect with the username and the password and the connection string of the particular SQL that you're using, the Oracle SQL you're using, and we are giving cursor connection here. And first we'll drop, since we might be running this multiple times, same table creations may cause a problem. So first, if we check if the required tables are present, and if they are present, we are going to drop them. As you can see, for we are using a for table to execute this query, like a drop table. For we are iterating through the array to delete each, if they exist, delete each of the tables, and if and then print the table has been dropped successfully, else the table does not exist, skipping drop. And after that we move on to creating the queries for creating tables. So yeah, here the first part we create the publishers with publisher ID with the data type varchar2, and which is a primary key with the publisher name varchar250 and address varchar. Then we create the table for categories using the same like the syntax which we have already seen, where the primary key is category ID and the category name has a varchar2 as the data type. Then moving on to books, here is where we see constraints. It's also similar. We have book ID as a primary key and the required title, description, varchar2 data type, and publication date, publisher ID. Here, the publisher ID and category ID are the foreign keys we have used here. And then we have the ISBN number, which is a unique number of the, and we have used unique constraint here since it should be unique for each book. And for defining the foreign key, we have used constraint keyword to reference the publisher's publisher ID as the foreign key for this table. And similarly, we have done category ID from categories for the foreign key. We have done this after publishers and categories because we have to create the tables. We have to first create the tables of publishers and categories before using them as foreign key. Then we create the members where we have member ID as the primary key, first name, last name with the varchar 2 as the data type, and 50 as character length. We have address, street address, city address, state, and zip code. And member type also we have. And here we have a check constraint where this, like we have said before in the ER diagram, when I explained this, so we told the constraint is that they can only be student or faculty, so we have this constraint. And for authors, we have author ID as the primary key, first name and last name with the varchar 250. And for loans, we have loan ID, book ID, where loan ID is the primary key. And here you can see book ID is from the books table. So it's the primary key of that table. Which we'll be using as a foreign key here. Okay, and we'll also have member ID from the members table as the foreign key here, and loan date, due date, and return date also as date. Yeah, then here is, and this is where we apply the constraint for foreign key for both the book ID and member ID. Then we have book authors, where we have book ID and author ID, which are both foreign keys from books and authors respectively. And the primary key constraint is book ID, comma. So it's a composite primary key. Like there are multiple columns for as the primary key, and we have referenced the foreign key here, so, like I told before. And for events, we have event ID as the primary key, event name varchar2 as the data type, and we are similar. We have date for event date, location varchar2, and description varchar2 of 100. Then we create member events, where like which all members and what event they have participated in. Where member ID and event ID are the foreign key from the respective member and events table. So yeah, the primary key is the combination of these two, and they have referenced these members. And moving on, we like then we'll run like these commands are in a list, and we'll iterate through each and every one of them, and then we'll print. If it is successful, we'll print the table created successfully, and we'll commit the transaction, so that the connection is the like the SQL query is sent to the database, and the final out like the changes are done. And after that, we'll if any error occurs, we print error in database operation, and finally we close the cursor and connection. We close the connection between the SQL interaction. So let's run and see this. So run. Yeah, as you can see, these tables I already created them before while I was doing this code, and as you can see they have dropped and they have been created successfully. Now let's move on to the second part of the like the interaction, the interface, which is about inserting the records. So here similarly we'll need to use the username and password to create the connection and the connection string. Here we also need to import extra date time for the like inputting the records, inserting the records, because we need to insert dates also. And we're using tablet because to like beautify the outputs to show in a tabular manner, just like what we would get in SQL, normal SQL, like Oracle SQL. And yeah, we use in a try block. We create the connection, we connect and start the cursor to for the execution. And first we start with the publisher table. This contains a list of it's a list of tuples where each tuple contains the record, each record for the like each record for the each record for the publisher table. And these are the records. As you can see, this is the publisher ID, publisher name, and their location. And after that, we use the a cursor dot execute many to run this query. So I forgot in like in the previous code also we'd have used this to run the commands. Basically, what it does is it reads through the list and it reads through the list and inserts each element into this. And after that, we commit after insertion, so that the output is sent to the correction is sent to the database. And after that, to check whether this is whether we have inserted everything correctly, we use the execute command to execute a single line to check the table to check the records from publishers. And we store that records to publisher fetched, and we use that to print the table. And here you can, as you can see, this tabulate to print each and every like to print in a tabular form. And these are the column names that we are specifying, and the format is PSQL. And similarly, we do that for category also, which is this is the category ID and this is the category name. And similarly, we execute like we iterate through all these records and insert it to categories, and we commit after insertion. We commit this transaction after this transaction, and then again we check. We'll print the categories table to check if all the records are inserted or if there are any errors. And it will be displayed with the category ID and category name as the column names. And then similarly, then we also do the same for books, where this column is the first column is for book ID, book name, a description, the date, publication date, a publisher ID, category ID, and ISBN number. And we insert about 15 books. And similarly, we insert these elements using the execute many command in the cursor and commit this insertion. After the insertion, we commit. Then again, print the books to see if they are returned, if they are like appropriately or correctly inserted. And similarly, we do the same for members table, where this is the member ID, member first name, last name, their street address, area, and state, and pin code, and their cat like what are their member type, like student or faculty. And we execute these each one by one and insert each value one by one and commit it. And after that, we again print those values to check if they're inserted. And that is also and it's also done for authors, same like what we have done exactly. So from now on, I'll just try to shorten it, as it's pretty repetitive. So yeah, this author ID, these columns, and we again check if each insert it one by one and commit it. After that, we execute to see the record and return the record in a tabular form with these column names. And we do we do the same for book authors also, where this is the book ID and author ID, and do the same which we have done already, like insert these records and commit. And for book authors, we print and see if they are inserted. And loans also, we do that. We do the same, where loan ID, book ID, member ID, a loan date, and on the required information. We insert these and commit it, and then we select the loans to see all the inserted elements. Again, for events, we have the same, then yeah, we have the same for we do the same for member events, and I guess you get the point. Now after this, if there is any error, we roll back. We roll back and do we roll back the connection and finally close it. So let's see the execution of this code. Yeah. So as you can see, these the records are inserted successfully. As you can because this is the output we got from the SQL, and there are no errors. There are no errors. As you can see, this is for the publishers table. This is for the categories table, and this is for the books table. This is for the members table. Members, yeah. So the members are the records for members tables is successfully inserted, and the authors also we've been able to successfully insert. And that's the same case for all the tables, such for like the remaining tables also, such as book authors and loans, events, and member events. So now let's move on to the last part, where I execute each and I execute the queries that I have done as DA1. So we'll move on to the queries code. So yes, here also we import the same function Oracle for the Python and SQL interface, and we create the connection and start the cursor, create a cursor object. First, we are going to the first command is to a DDL command to create a table for book reviews. We already seen the DDL commands for other tables before, and this is the similar. Here we insert we create the table book reviews with review ID as the primary key number, and book ID, and the remaining entities are like the remaining, what do you call, the elements such as book ID with varchar 2 data type and member ID. Yeah, these are the foreign keys from book and member table respectively, and we have the review date and review text, the review of those. And after this is done, we print that the books tables are successfully created. Since we have created this table, and for the future, like for the upcoming queries we might need to extract some info, we will be adding some data to it as well. Here you can see we are having a list of tuples as we did before, and we are entering, like what do you call it, we are executing this command to insert elements, these elements. This is not asked in the questions, but since will be requiring this table in the next questions, I have done this. So as you can see, this contains the records for the reviews table, and we insert this record, and we return that the records are inserted successfully. Else we print error in inserting. Then the second question is a DDL command, where we add a columns to the add a column to the books table. We like Here the column we are adding is a rating, which has a check constraint, so that the rating is between 1 and 5. with a data type of number 2. So yeah, this is an added functionality to see the ratings of the book. And after this has successfully executed, we'll be returning that the table column is successfully inserted, the column is successfully created, and then we'll insert some values for some books
some books.
alone, so, like since we may need for other queries. And here you can see that uh, yeah, we insert these values and we also update. We also have another query, like subquery in the same question. For the second question, we update the books where we say where we change the book ratings to 1, where book ID is 2 rating, and we commit this transaction and print that it's successful, else we return an error. So for the third, we use a DML command to update DML query to update book rating. So here, like it's similar to the one we have done before, but yeah. So here we update the books table and set like a rating column to like rating value to 4, where book ID is equal to B1. So we are just changing the rating of a book of book ID B1, and we commit it and we return that it's successful. Else we return an error. And after this change, we have to check if it is if the change has been done successfully. So we print the table in the tabular format using the tablet function and the execute function to execute the query and fetch all to uh, like to get the store the query as a in a variable to print it as a table. And then for the fourth one, we use a DML query to delete return loans. So, as you can see, the from the loans table, there are some tables which may have return date as not return date as null, like return date as not null. Like they have some values which is not null. So we are going to be removing only those values here. And we after this is the query to do that, and we commit the query, so it's executed, and we return that it's successful. And then we print from then we again print it such so that we know everything is like the code is working properly, and and after that we could be able to see that the loans in the loans table, the entries of records which may have been returned are deleted. And then for the first question, we have retrieve members who borrowed books from Penguin using join method. Here we'll be joining three tables. We'll be returning the first name and last name from members M, where we join loans, where member ID from member is equal to L dot member ID, and then we join books from L dot book ID, like loan book ID from loan is where book ID of loan is equal to book ID from books, and join publishers where the publisher ID from the books and the publisher ID from the publishers are same. And the last constraint is our main aim here, which where we check if the publisher is Penguin Books, and we execute this and return the table query. Now moving on for the sixth query, we will be calculating the average rating of books for each publisher. This type is called aggregation. We will be using aggregation function. So here also we'll be using join to join publisher and books. So the column which we'll be seeing is publisher name and the average rating as average rating, and we group by the publisher name. So
Yeah,
so
so
we store the return value, we store the output, and we return to the user in the using tablet as always. And then for the seventh question, we'll also be using aggregation, where we'll find the total number of books borrowed by each member. Here also we'll be using join because we'll be joining the values based on members and left join loans. Here we are using left join because we only need values which are in M, which are mainly in M. So if they are in L, if like M, in the sense I mean the values which are in members, but not specifically the values which are in the member ID, which is in loans that is not in members. So we are using left join here. We join members and loans where the member ID of both of them are equal, and the column will be printing as first name, last name, and the count of the loan ID as total books borrowed. Where this is the aggregation function we're using to count how much they have borrowed and group by their first and last name. And then we'll return the output in as a tabular form using fetch all and tabulate functions. Then for the eighth question, we'll list books with number of reviews. Yeah, so as you can see, we are using book reviews here, which are created before. So here we left join books and book reviews on book ID because they are the common column type or common column where we return the title and the count of the review ID as review count. So how many
how
review
many
ID we have got for the same book as review count. Group it by title because for we are finding the count for each title and order by review count, descending in the sense from most reviewed to least reviewed, and then we execute this and return it to the return it to the Python console using tablet with the uh, necessary column names. And then for the ninth question, for the ninth query we get the most recent loan date for each book using date functions. Here we find here we execute the query using the syntax like given below. The title from books table and max of loan date for the particular book as most recent loan date from books left join loans, where the book.book ID is equal to loan.loan ID. This is the connect. This is the comparison, and we group by the title. As shown for each book, we are finding the latest. Like we are doing this because each books may be a loan may have loan dates of multiple days before, and we are going to just retrieve the latest loan date, and again we fetch the result and print it to the user. And for the 10th query, we want to know which all authors have written books in the fantasy category, which uses join function here. Here we select distinct name from authors, and join authors with book authors, book authors on author ID because they are that is the common key, and we join book with book ID. We join book with book authors on book ID, and categories and books also with category ID, where category name is equal to fantasy, and we return the first name and last name of the uh, as you can see the query we have executed the query using the execute function for the cursor with highest rated as select publisher comma max rating as here using nested queries here as highest rating from books and group by publisher ID. So we are finding the max rating, and we select from the publisher name comma title comma rating as highest rating from books, where we join the publisher and books on publisher ID from books and publisher ID on publisher, and join highest rated on b.publisher ID is equal to hr.publisher ID, and b.rating is equal to hr.highest rating. So this is the table we have created. This is the temporary table we have created that we are using here. We will compare the highest author and we'll order by the publisher name. And we'll similarly, as we have done always, we fetch the result and return it to the user with the publisher name, book title, and the highest rating. Then we move on to the 12th query, where we find the members with the most borrowed books in the last year. Here we will use the aggregate functions to count the maximum. Yeah. So we'll return the first name, last name, and count of their loan ID from their loans as total borrowed from members where we join loans and members based on their member ID, where loan date is greater than 2, so greater than minus 12, in the sense that it checks if the loan date is greater than the current date by minus 12. That means it's more than a year. It has been more than a year before for, they have borrowed their books. Like more than a year since they borrowed their books, and grouped by the first name and last name, and order by total books, total borrowed, descending in the sense that we order them from like the user with the most borrowed books to the least books borrowed more than a year ago. And then we return to the user with the column names, first name, last name, and total borrowed. For the 13th query, we check the books with the most reviews and their average ratings. So for the 13th query, we will be returning the books with the most reviews and their average rating. Here we will be returning, as given, we'll be returning the title and the count of the reviews they have got from the review ID as review count, and their average rating as average, and their average rating from the books table, where we join the books with left joint with book reviews, because the main focus is on books. So the values from all the values from books are returned, even when book reviews may have null values for that. Where the book ID from books and reviews is same, we group by the title to get for the aggregate functions, and we order in descending order from the highest to the lowest rating. Then we execute it. Uh, we execute the query, and we fetch the result and return the print the table using the tablet library. And for the 14th query, we'll be returning the books that are not borrowed yet. Not borrowed yet. Here, the logic is that we'll see the borrow date, and if it is null, we'll return only those book loan ID which is null. Not that, like in the if the table is not does not have a loan ID in the loan table, then that means uh, means that it's not been borrowed. So this is a simpler query. We just left join from books and loans, with book ID from books is equal to book ID from loans, where loan ID is null, and we fetch the result and print the value. And for the last query, we are asked to return top three authors with the most books published. Uh, Here we have a nested query where we select star from the name, first name, last name, from the author's ID, from the author's table, and book ID from the books. We count the book ID as total books from authors A, from authors, where we join book authors and authors on author ID, and join book like book authors on book ID, grouped by the first name and last name of the authors, and ordered by the total books. And we limit it to the first three rows, as we are asked only the top three authors. And after this is completed, we'll fetch the result and we'll print the table. And if any error occurs in this, we'll return that the database connection has a problem. And then we close the cursor for execution, and then close the connection between the SQL server. And now let's run this and see the result. So you can see it's already, so table creation. Yeah, because I had already created it before, so it's not properly visible. And you can see the ratings. The rating column has been added successfully to books table, and we can also see that books rating table has been updated successfully, where we have added rating. See, you have seen the new column. You can see a new column called rating, which was not before. Yeah, this is the books column from before, which doesn't have a rating, but now it has. But now it has. And then for the fourth query, we had deleted the return loans, and we can see this is the
This is the
updated one, where we have no return date. We have deleted it. Like we can see 1 3, you can see the missing values. While in the previous case, when I inserted them, it was continuous, like L1 to L10, which had return date, but those are deleted, as you can see from this result. And we are returned. borrowed books from Penguin, like members who borrowed books from Penguin Books, Alice Smith and Jack Wilson. As you can see, members will go to members. Yeah, they bought. Alice bought from B1, which is from Penguin Books. P1 is Penguin Books, so it's correctly returning the names. Now let's move on to the next value for the sixth query, where we are returning the average ratings for each publishers. As you can see, these are the average values, and the empty values are the values where we didn't have any ratings for them. And then we return the total number of books borrowed by each member. Here you can see the members. Here the first name, last name, and the books they have borrowed totally. For the books with the number of reviews, this is the output where we get the book title and the review count with the number of reviews by the review ID each book got. Then we have most recent loan date for each book. Uh, Here we are printing, as you can see, we are printing these books and their most recent loan date, the last loan date, the return. These are null values, so they don't have any. Uh, they don't have any values present. Then for the tenth, we have authors who have written in the fantasy category. We have got the output we have got is George Orwell and Mary Shelley. Let's see if this is correct. We'll go to category. Yeah, you can see for fantasy we have C1. C1 is fantasy. You have got C1 two times here and here, which is written by book ID is the book ID is B3 and B3 and B10. Let's look into them. B3, B10. Yeah, B3 and B10 is A4 and A11. 3 and book 11, 4 and A12. Yeah,
Yeah.
so we
So
get the same result here. So we have verified that the results are accurate. Now we'll move on to the highest rated books by each publisher. We'll see the publisher name, the book title, and the highest rating. And for the 12th, we have the members with the most borrowed books in the last year. Here we are returning in the descending order from most to least. Since they are only borrowed once, it's same here. For the 13th, we have books with the most reviews and their average rating. The book title, we have book title, review count, and average rating, which are correctly displayed. These are for these, the values are null, so they are not displayed. Here we are seeing the book titles that are not being borrowed. That means they don't have a loan ID as of now. And then the top three authors with the most books published, we have these three authors. Since they are one, it doesn't have an effect, so it's just printing the first three authors. So as you can see, every query is working perfectly. And with this, I would like to conclude my video and thank you for watching.